Have you ever gone out on a clear night, looked to the horizon, only to notice a gigantic moon staring back at you? Surely this is the biggest you've ever seen it. Maybe it's just closer to the Earth today? But what if I told you that that moon is the exact same size as every other time you've ever seen it in the sky, and it was in fact playing a trick on your brain? It's called the moon illusion, though an explanation of this optical phenomenon is still debated. What we do know is that when the moon sits closer to the horizon, it seems bigger, but if we measure it in the sky, it's the same size. You can test this by holding your thumbnail at arm's length and comparing it to the size of the moon. Do this when the moon is near the horizon and high in the sky, and you'll notice it doesn't change size. So why does our brain process it so differently? The main theory suggests that when the moon is near the horizon, there are many visual reference points, trees, buildings, mountains, with which its size may be compared. But when the moon resides high in the sky, there's nothing around it to compare, and it seems smaller against the vastness of the night sky. It's similar to an effect known as the Ebbinghaus illusion. Which of these orange circles is larger? It turns out they're the exact same size, but the objects surrounding them have an effect on our brain. The small circles are comparable to the horizon moon with smaller objects in sight, while the large circles are comparable to the high moon surrounded by vast night sky. Furthermore, our brains are used to objects moving towards the horizon becoming smaller, like clouds. So when our brain sees the moon at the horizon appearing the same size in our retina, it compensates for perspective and assumes it must now be physically larger. Still not convinced? Try bending over and looking through your legs at the horizon moon. The effect is gone because upside-down trees and buildings don't register as familiar objects and your depth perception isn't confounded. Or, for the less flexible, take a photo of both moons. Your camera won't suffer any optical illusions and you can clearly see the moon is the same size. Got a burning question you want answered? Ask it in the comments or on Facebook and Twitter, and subscribe for more weekly science videos.